Is my screen visible? Am I audible, guys? Mukut Karan? Okay. Okay, so let's begin. Welcome to the Q&A CPF solving session. And guys, today we have Codeforces Div3 1027 round. So guys, just quickly tell me how many of you have participated in today's contest. Guys, have you participated in today's contest? So how did you find the contest? Was it easy? Was it medium? What was the difficulty of the contest? And how many problems were you able to solve? Okay, nice, Ashish. Okay, so we will be discussing the first four problems of today's contest, A, B, C, and D. Okay, nice. So, guys, let's begin with the very first problem. Okay, so yeah. So this first problem name is square year, and it states that you are given a year represented by a string S consisting of exactly 4 characters. Thus, leading zeros are allowed in the year. Okay, representation, for example, like these are the string of length 4. These strings could be your years are valid representations. You need to express it in a form of a plus b whole square, where a and b are non-negative integers, or determine that it is impossible. So yeah, this problem statement is pretty simple. Like we are given a string of length 4, and what you're supposed to do is supposed to check if the integer version of this string has the perfect square or not. Is the problem statement clear, guys? Is it clear? What is the problem statement? Like we have a string of length 4, which is representing a year, and what you're supposed to do is supposed to check if it is possible to have this representation of the number of the year, which is a plus b whole square. So guys, we have this string of A, B, C, D. So these are the 4 characters, a string consisting of these 4 characters. So we will be converting this string to an integer, and we are interested in knowing if there exists some number, let's say x, which would be nothing but, okay, let's have some different like, nomenclature. Like we will be having a string having S0, S1, S2, S3. So guys, S0, S1, S2, and S3 are the 4 characters. So we will be converting this string to the integer format, which is x, and we need to check if a plus b square, if this x can be represented in this form. So let's say this a plus b is equal to c. So we want to check if this is possible, because any integer can be decomposed, or we can write as addition of 2 non-negative integers. So what we can do is simply like put any of them a or b equal to 0. So the x can be represented as 0 plus c whole square, or anything. Like if it is like, you can do 1 plus c minus 1. So it's completely up to you. So guys, tell me if the problem statement is clear. Like we have discussed the solution, but still, if the problem statement is clear, then there is nothing in the solution, because what you're supposed to do is very simple. We have a string, we will be converting this string to the integer, and then that integer can be represented as summation of 2 non-negative integers. I mean, any integer x can be represented as a summation of 2 non-negative integers, because we can see this a and b are non-negative integers. So 0 is also non-negative, so we can represent x as 0 plus x. So my first non-negative integer would be 0 and my second non-negative integer would be x itself. So the task is to check if this x has a perfect square root or not. So for example, if I have 9, then I can represent it as 0 plus 3 square. If I have 16, then I can represent it as 0 plus 4 square. But if I have 5 or if I have 7, so for these kind of number, we cannot represent, we don't have such representation. Okay, so the solution must be clear, guys. So guys, please write yes in the chat if the solution of the first problem is clear, which was very simple. Like all you have to check is whether their square root exists or not. Okay, so guys, how you will be checking whether there exists a square root or not. So there are multiple methods depending which programming language you are using. The one that you can do is just calculate the square root. Just calculate the square root of n and take the seal or the floor of this. Let's say we take the seal and we store this into s, and we will check if s into s is equal to n. If this is the case, then we can say yes, there is a perfect square root of n. Otherwise, we will say there is not. If there exists a perfect square root, then the answer would be 0 and n. 0 will be representing a and n will be representing b. Sorry, square root of n will be representing b. Yeah. So guys, that was the first problem. Let's see the code for the first problem. So that was a simple, like I'm converting the string into integer and then I'm checking. So guys, this is like the square root. So it will be so the square root would be in double. So its floor will be automatically assigned to SQ, and I'm checking if SQ into SQ is equal to n. If that is the case, then I'm returning this 0 and square root. Otherwise, I'm returning this -1. So yeah, that was about the very first problem. So guys, is there any doubt regarding the first problem? That was pretty simple. So should we move forward to the second one? Okay, so let's move to the second problem. How many of you were able to solve the second problem, guys? Just write yes. How many of you were able to solve the problem B? Okay. Okay, so let's jump to the second problem. So not quite a palindromic string. Okay, so we have a string. Okay, it's a binary string, as we can see, 0 1 0 0. There is only one good pair. Okay, so yeah, this we will be reading from here. So we have a binary string S of even length. Okay, even length. So we consider a pair of indices I and n minus I plus 1, where I belong to this range. Okay, to be good if S of I is equals to S of n minus I plus 1 holds true. Okay, so for example, we have this binary string and we will check if, okay, so there exists only one good pair because S of 1 is not equals to S of 6. So we are comparing this very first element to the last element. And then we are comparing second with fifth. Okay, so it means we are comparing second element with the second last element. Okay, then we are comparing third with fourth. Okay, so we are comparing the third element with the third last element. So after this three comparison, only this satisfies this particular condition which is given above, because the third element is equal to the third last element. So that's why in this particular string we have only one good pair. We have only one good pair. And we have another example. So guys, as we can see, there is no good pair because first element is not equal to the last element and the second element is not equal to the second last element. Okay, so now we know what is a good pair. So guys, what is a good pair? If the ith element is equal to the ith last element, then I will say this is a good pair. Okay, So we want to rearrange some characters of the string so that there are exactly k good pairs. So guys, what we can do, we can rearrange these zeros and one, and after the rearrangement, we want exactly k good pairs. So that was about the problem statement. Is it clear, guys? Is it clear? So guys, we have a binary string. Binary string is a string that is consist of zeros and one, and we want to check if there exist exactly k good pairs in the string after the rearrangement. So what we can do, we can perform any sort of rearrangement to the string, and after the rearrangement we have to check if there exists exactly k number of good pairs. What is a good pair? Good pair is a pair if the ith element is equal to the ith last element, then this pair of ith and the ith last would be a pair, and it would be a good if the values at these position would be equal. So the problem statement is clear. So let's see how we can proceed. So like what we want is we want exactly k number of good pairs, and we have zeros and one in the string. So how to proceed? Okay, so if I want a good pair, then I have to place same value at the ith and the ith last element. 1, 2, 3, 4, 5, 6, 7, 8. So whatever value I am putting here, the same value I have to put here. Okay, the thing is n is even. N is even. N is even, guys. N is even. So if I am putting here 0, then I have to put here 0 in order to make a good pair. But I don't want any number of good pairs. I want k number of good pairs. Okay, so first of all, we can rearrange the string. So guys, the better option would be to just check the number of zeros and ones. Let's see the test cases. Let's see the test cases for better understanding so that we can think in some direction. So we have this string consisting of all zeros. So we have this string consisting of all zeros. How many zeros we have? We have 6 zeros, and we want two good pairs. So 1, 2, 3, 4, 5, 6. We want two good pairs. Guys, can you tell me how many good pairs do we have in for this particular string? How many good pairs do we have? Okay, yes, exactly. We have three good pairs. We have three good pairs. 1, 2, 3. So what I want, I can do rearrangement, but as you can see, this particular test case has all zeros, so it is not possible to rearrange this string in such a way such that we end up in getting two good pairs. So for this particular test case, we will return -1. It is not possible actually. So we are supposed to return no actually. So not -1, no. We will say no. We will say no. For this particular test case, we will say no. Okay, for the second test case, we have 0 and 1. Okay, simple test case. 0 and. How many good pairs do we have, guys? How many good pairs we have? 0. Minimum of count of 0 count, and okay, so we have this approach. Abhiram is saying, can we check the minimum number of zeros and 1 if that is lesser than or equal to k? He is saying that minimum of number of zeros and number of ones, if this thing is less than or equal to k, then we will say yes. If this is true, then what would you say? If this is true, then would you say yes or no? Yes. If this condition is true, then you will state yes. Okay, so let's see if this thing is true for this particular test case. 0, 1 and 1. 0, 1 and 1. So minimum of 0 and 1, minimum number. So the count of 0 is 1, count of 1 is 1, and the minimum of 1, 1 would be 1. Okay, so for this particular test case, this is working. And for minimum of zeros, this is 6, and minimum of 1 would be 0. So minimum would be 0, and 0 is less than 2. Yes, for this particular test case, your approach won't work, Abhiram. In this test case, the minimum number of zeros and 1, the minimum number would be 0, because we have 1 which is equal to 0, and 0 is less than or equal to 2. 0 is less than or equal to 2. So for this particular test case, your algorithm will return yes, but that is not correct. We want no here. Okay, so let's move with this test case. This is good. Let's move with these two test cases. So we have 1 1 0 1. Yeah, 1 1 0 1 0 1 1 0 1 0 1 1 0 0 1 1 0 0 1, and we want 2 for 2. We'll see for the 2. Let's see for the 1. Let's see for the 1. Okay, so I can do 1 2 3 4 1 2 3 4 1 2 3 4 5 6. So guys, I have 4 number of zeros and 6 number of ones, and I want one good pair only. One good pair. Guys, can you tell me how many good pairs do we have in this string? How many good pairs do we have in this string? 5 good pairs. How many good pairs do we have in this string, guys? 5 0. Anyone? Guys, I want answer. Everyone should write answer in the chat. What are the number of good pairs do we have in this particular string? We have this 4 zeros and we have 6 ones. Yes, 1. Correct, Ashish. So as you can see, there is no match, there is no match, there is no match, there is no match, but there is a match. So we have only one match. So for this particular string, we have only one good pair. So, and this particular string is the rearrangement of that string. So yes, we can rearrange this string in such a way such that we end up getting only one good pair. Okay, so let's see this test case. Can we rearrange this particular string in such a way that we'll get 2 good pairs? Can you rearrange this string in such a way that you will get 2 good pairs? Is it possible, guys? What do you want? You just want to increase this number by 1. You just want to increase this number by 1. You just want to increase the number of good pairs by 1. Is it possible? Is it possible? No. Let's see why it is not possible. Guys, if you cannot increase the number of good pairs by 1, it is not possible. See why. If I want to increase the number, see, this is the minimum number of good pairs that we can achieve. This is the minimum number of good pairs that we can achieve. Guys, if you will sort the array, if you will sort this string, there will be all the zeros one side and there will be all the ones one side. So there will be maximum. So this particular sorted string will give you maximum amount of unmatching, because for the initial ith, for the first number of zeros, like let's say if I have k number of zeros, so guys, you will get k unmatches, at least k unmatches. If I'm considering number of ones are greater, because these k number of zeros will be matched with ones only. So there will be k number of unmatching. If one is equal, one is greater than or equal to number of zeros. Is it clear that why this configuration will give you minimum number of good pairs? Is it clear, guys? Guys, just respond if it is clear that sorting the string will give you the minimum number of good pairs, because when you sort, then the zeros will be matched, because we want to match with the last element. So the first zero will be matched with the last one, and the second zero will be matched with the second last one. So this is the optimal configuration to get minimum number of k, minimum number of good pairs. Isn't it, guys? Okay. So this configuration will give me the least I can achieve. This configuration will give me the least I can achieve, and this configuration can be achieved by absolute difference of number of ones minus number of zeros. Because guys, we can have a case where you will get 6 zeros and 4 ones. In this case, you will have only one good pair. So that's why I'm taking absolute difference between number of ones and number of zeros. This is your minimum k. This is the least k that you can achieve. This is the least k that I can achieve. Okay, so we have seen the least amount of good pairs that I can achieve. Guys, let's see what is the maximum amount of good pairs that we can achieve. Guys, if I want maximum amount of good pairs, so I will be matching 0 with the 0 and 1 with the 1. If I want to achieve the maximum configuration, then I will be matching 0 with the 0 and 1 with the 1. Let's say I have any this 0, 0, 0, 1, 1, 1, 1, 1. So I will be taking this one, and this one so I am putting this one to the front, this one to the last, this one to the front, this one to the last. 1, 2, 3, and 4. Yes. This one to the front, this one to the last, this one to the front, this one to the last. This 0 here, this 0 here, this 0 here, and this 0 here, and this 0 in the middle. Okay, we have even, we have string length even, huh? And this is odd. So let's increase the 0 by 1. So 1 will be matched with 1, 1 will be matched with 1, 0 will be matched with 0, 0 will be matched with 0, 0 will be matched with 0. So guys, the number of pairs will be, number of good pairs will be 1, 2, 3, 4, 5, 5. So guys, if I want to achieve maximum number of good pairs, I will be pairing zeros with zeros and ones with 1. So guys, if I have n number of zeros, then how many pairs having zeros, having both zeros can be there? If I have n number of zeros, then how many good pairs that I can have? Those good pairs which will be having 0 only. If I have n number of zeros, then how many good pairs, what is the maximum number of good pairs I can achieve? So let's say I have 4 zeros. So how many good pairs I can have? N by 2. Yes, exactly, n by 2. And same is the case with 1. If I have n number of ones, the maximum number of good pairs that I can achieve is n1 by 2. So guys, n0 by 2 plus n1 by 2. This is the maximum number of good pairs that I can achieve. So guys, the first observation was, this is the second one. The first observation that the absolute difference between number of zeros minus number of 1, this will give me the minimum number of good pairs by 2. This will give me the minimum number of good pairs that we can have. Guys, we have to divide by 2 also. 1, 2, 3, 4, 5, 6. So the difference is 2. But we want pair. So that's why we are dividing by 2. So this will give us the minimum number of good pairs. This will give us the maximum number of good pairs. And the third observation, 0, 0, 0, 0, 1, 1, 2, 3, 4. So guys, this is giving us the one number of good pair. Can I rearrange this string in such a way that will give me 2 number of good pairs? Is it possible? We have seen this configuration earlier, can you tell me if it is possible to achieve two number of good pairs by rearranging this particular string? Is it possible, Abhiram? Okay, no, it is not possible. Why it is not possible? It is pretty simple. If I will not be touching this pair, I will not be touching this pair. I want to increase only one pair. So I will be putting this 0 in front of this 0. So the front of this 0 would be here. So I want this 0 to be here. So okay, I am removing here. I am removing this one. So I am removing this one. And this 0. So I will be putting that 0 here. Guys, now for this one, the only position which is left, that is this. But now you guys can see there are two, the number of good pairs increased by 2. As you can see, this is also a good pair. Now this is also a good pair. So guys, the number of good pairs will always increase by 2 or by 4 or by 6. You cannot increase the number of good pairs by 1, 3 or 5 by the odd number, because when you swap a 0 with 1, then there will be a matching with 0, but there will become another matching of that one also. That's why it is not possible to increase the number of good pairs by 1. Is it clear, guys? Is it clear? Is it clear that why we cannot increase the number of good pairs by 1? Okay, so that was about the problem. We have the minimum number of good pairs. Let's say minimum number of good pair is absolute of n0 minus n1 by 2. We have the maximum number of good pair, that is n0 by 2 plus n1 by 2. And we just have to check if the k lies in between or not, but that k has to be with the difference of 2. Like you can check if whether the k is equal to this or this particular quantity plus 2, then plus 4, and so on. It cannot be any number in between this range. That has to be with the even distance from this. That has to be with the even distance from this. So guys, let's see the code. Let's see the code of the second problem. So guys, here I'm using loop, but it is not necessary to use a loop. But the like you can make a loop here, but the optimal choice would be to check whether the difference from the minimum and the current k is even or not. But you can also do this. It will not end up in TLE. So here I am just calculating number of zeros and number of ones. So the minimum number of k that I can have is this, and the maximum is this with the difference of 2. If we get any I, that will satisfy the k, then I'll return yes, else no. So that was about the second problem. Is it clear, guys? Do you have any doubt in second problem? The problem was good. All we need is just 3 observations. Should we move forward to the third problem? Okay, so let's move forward to the third problem. Okay, so this third problem is need more arrays. Okay, so we have given an array of integers. It is sorted in non-decreasing order. So okay, so first of all we have array and it is already sorted. Fine. You can remove any number of elements from the array. Okay, including the option of not removing at all. Okay, we can remove any number of, like we can remove zero number of elements from the array without changing the order of the remaining elements. After the removal, the following will occur. So the first thing, we have the array is sorted. The second thing is I can remove any number of elements from the array, but after removing the elements, the order of the array will not change. It means after the removing, the array will remain sorted, isn't it, guys? The array is already sorted. If I will be removing a subset from the array, then the remaining array will ultimately be sorted. Okay, so that is very basic observation. Okay, so after removing, we will be seeing this. If even okay, A1 is written to a new array. If A1 plus 1 is less than A2, if A1 plus 1 is less than A2, it means the difference between A1 and A2 is greater than 1. It means the difference between A1 and A2 is greater than 1. Then A2 is written in a new array. If the difference between A1 and A2 is greater than 1, then I will be writing A2 into the new array. If the difference between A2 and A3 is greater than 1, then I will be writing A3 to a new array. Okay, so I will be removing some element from the array, then I will get another array that will be sorted. If the difference between any two consecutive elements is greater than 1, then I can write that particular element to the new array. Okay, so for this example we have 1, 2, 4, 6. So 1 is written to a new array. Okay, 1 is here. 2, okay, so difference between 1 and 2 is not greater than 1, so 2 will be written in the same array. Okay, but the difference between 4 and 2 is greater than 1, so I am writing 4 in a separate array. And the difference between 4 and 6 is greater than 1, so I am again writing 6 in a different array. So at the end I have 3 different arrays. So your task is to remove the elements in such a way that this designed algorithm creates as many arrays as possible. If you remove all elements from the array, no new array will be created. Okay. Guys, is the problem statement clear? Is the problem statement clear, guys? So we have an array. So the very first thing is we have an array. I will be removing some elements from the array. I will be removing some element from the array. After removing, I will be applying the algorithm to the array. Which algorithm? This algorithm. This algorithm to the array. And after this algorithm, I will have some arrays. I will have different number of arrays. Okay, I will have different number of arrays. I want to maximize this number of arrays. I want to maximize this number of arrays. So this algorithm, I cannot do anything with this algorithm. This algorithm is constant part, guys. So this is the thing that I can do. I can make the removal of the elements in the array in such a way that I will get this array that will give me this maximum number of arrays. Isn't it, guys? Isn't it? Is it clear? Is it clear, guys? Okay. So this is the thing that I cannot change because this is a simple algorithm that I am applying to the array after the removing the element. But the removal of the element is something that I can control. Okay. So let's see what is algorithm. So algorithm will give us the idea that how we should proceed, how we should remove the elements from the array. So guys, the algorithm is simple. The algorithm is that if I have 1, 2, 3, 4, 5. So the consecutive difference between 1 and 2 is 1. So okay, this will not be removed, this will not be removed, this will not be removed, this will not be removed. So this array is, if I pass this array to this algorithm, I will get what I will get, guys. If I pass this particular array to this algorithm, what I will get? One. Sachin, one array, yes. We will get one array. And that array will be consisting of 1, 2, 3, 4, 5 only. Okay, if I pass this 1, 2, 3, 4, 5, guys, if let's say this 1, 2, 3, 4, 5 is here, which elements would you remove so that after applying this algorithm, I will end up in maximum number of different arrays. The algorithm is doing what? The algorithm is checking if the two consecutive numbers having difference less than or equal to 1. If the difference is less than or equal to 1, then there will not be any partitioning. Then there will not be any partitioning. If the difference is greater than 1, if the difference is greater than 1, then there will be partitioning. Then there will be partitioning symbol. Isn't it, guys? Isn't it? Okay, so we have this answer 2 and 4. So if I remove this 2 and 4, then there will be 1, 3 and 5. Okay, so let's apply this algorithm to 1, 3, 5. So 1 and 3 having difference greater than 1. Okay, so 1 and 3 and 5 will be separated. So 3 and 5, okay, 3 and 5 having difference greater than or equal to greater than 1. Okay, then this will be. So after applying this algorithm, I will get 3. I will get 3 different arrays. Okay, guys. Okay. So guys, here we got an observation. Here we got an observation. When I pass the array of 5 consecutive numbers, I will get 3. I will get 3. Okay, let's see. If I have 9, 10, 11. If I have 9, 10, 11, guys, this is the array of 3 consecutive numbers. So guys, which number will you be removing? In 9, 10, 11, which element you would remove in terms of maximum? Okay, 10. It is pretty obvious because we want what we want. Now we have observed. Now we have observed that we want to maximize. We want to maximize. We don't want the difference between adjacent element to be equal to 1 or less than 1. We want the difference to be greater than 1. That is why I am removing this 10. Because if I remove this 10, I will get 9, 11. And now the difference between the consecutive element is no longer less than or equal to 1. That is why I am removing this 10. So guys, if the length is 3, if I have 3 consecutive numbers, then I am end up in getting 2 arrays. So for the 5, I get 3, and for this 3, I got 2. Okay, guys, what if we have 1, 2, 3, 4, or let's say 6, 7, 8, and 9? Guys, what if I have 4 consecutive numbers? Then which number you will be removing? Then which number you will be removing? Or the 6, 7, 8? Or the 6, 7, 8, 9? We can remove 6, 7, 6, 8, or 7 or 9. So for this 4, we have only 2. For this 4, we have 2. Because when I remove 6 and 8, I will have 7 or 9. And 7 and 9 have the difference greater than 1. So again, we will have 2. We will have 2 different arrays. Because if you remove only one element, then 7 and 8 will not be removed. So if I have n consecutive elements, then I can see that I will get n plus 1 by 2. I will get n plus 1 by 2 number of partitions, or I will say n plus 1 by 2 number of new arrays. Isn't it, guys? N minus n by 2. N minus n by 2. No, that won't be the case. N minus n by 2 won't work. But yes, n plus 1 by 2 will work. N minus n by 2. That will be n by 2 only. Okay, so you're supposed to take the seal of n by 2. So that is why n plus 1 by 2. Because in case of 5 we have 3, in case of 3 we have 2, and in case of 4 we have 2. So that is why n plus 1 by 2. Is it clear, guys? Is it clear? Is it clear, Abhiram, Sachin, Ashish? Is it clear? Please respond. Okay. Okay, guys. So we have seen if I have n consecutive numbers, but in the array, it is not necessary that I'll always get, let's say the length of the array is n. Yes, it is possible. In this reason, I am getting consecutive. Then there is a break. Now here I have consecutive numbers. then here is a break, then here is only a single element that is consecutive, then here is a break, and then again a consecutive numbers. It is possible, guys, isn't it? It is possible that I am getting the consecutive because the array is sorted. Because the array is sorted, it is mentioned in the problem statement that array is sorted in non-decreasing order. So yes, I can have consecutive numbers in a series, like having difference greater than or equal to 1, less than or equal to 1. It is possible. So what I will be doing, guys, I will be iterating throughout the array, and I will be maintaining a counter. Isn't it? Let's have a test case. Let's create our own test case. We have 1, 2, 3, 4. Now I have 7, 8, 9, and 11. And then we have 13. And then we have 15. And then 16. Okay, so guys, let's maintain a counter. I have a counter. So this counter will be checking the difference between these two. The difference between these two is 1. Okay, if the difference between these two is 1, counter is initialized with 1, then the counter plus plus. Now the value of the counter is 2. Okay, difference is 1. Now the value of the counter is 3. Okay, difference is 1. Now the value of the counter is 4. Now difference is not 1. Here the difference is not 1. Okay, if the difference is not 1, then I will be maintaining another variable answer, in which I will be storing the answer. Answer is initialized with 0. So guys, here we know that there is a break. So if here condition breaks, it means what, guys? It means I am done with the consecutive. I am done with the sub array having difference equal to 1. Isn't it? It means I am done with the array having consecutive equal to 1. So that's why answer plus is equals to count plus 1 by 2. If the difference is greater than 1, then answer plus is equals to count plus 1 by 2. Here the count is 4. 4 plus 1, 5 by 2. 5 by 2 would be 3. 5 by 2 would be 2 only, sorry. So that's why now my answer will become 2. Okay, now this counter will become 1 only. So the 7 and 8, okay. 8 and 9, okay, the difference is 1. 9 and 11, no. Another break. Counter is what? Counter is 3. So guys, 3 plus 1 by 2, which is 4. 3 plus 1 by 2, 3 plus 1, 4, 4 by 2 would be 2. So again, I will be adding 2 to the answer, so answer will become 4. And counter will become 1. Okay, 11 and 13, no. 11 and 13, another break. So answer plus is equals to 1 plus 1 by 2. 1 plus 1, 2 by 2, which is 1. So 5. 3 and 15, nope, another break. Counter will become 1 again. So 1 plus 1 by 2, another increment 6. 15 and 16, yes, 15 and 16, so counter plus plus, so counter will become 2. So for after 13, this 15, for this 15, this counter will become 1. And for the 16, this counter will become 2. Okay, now we have reached to the end of the array. So we will be computing again this count plus 1 by 2. So which is 2 plus 1, 3 by 2. And base 3 by 2 would be 1. 3 by 2 would be 1. So this would be 7. So for this particular test case, we will have 7. 1. Okay, let's see. If I remove this, then this array. If I'll remove this, then this, then this. This is the reason, and then this. 1, 2, 3, 4, 5, 6, 7. Yes, this algorithm is working fine. This algorithm is working perfectly. Is it clear, guys, how by maintaining a counter we can achieve this? Because we have observed that if I have a sub array having a consecutive, subarray of consecutive numbers of 1, 2, 3, 4 of n consecutive number, then I will have n plus 1 by 2 in the end. Okay, so guys, we are not done with the approach. Like we are almost done, but we haven't covered that test cases like 1, 2, 2, 3, 3, 4. What will be the answer for this test case? What will be the answer for this test case? Guys, this 2 and this 3 is not contributing to the array, isn't it? Isn't it? This 2 and this 3 is not making any difference. Like the answer for this array is equal to the answer for this 1, 2, 3, 4. Just think, guys, just think. What these, because the array is sorted, the array is sorted. So these additional, like any number of 2s, any number of 3s, the answer for this and this would be same, isn't it, guys? You just think. Just take your time and you will come to a realization that yes, this extra number of 2s and extra number of 3s are actually not putting anything, they are just occupying the space. Like they are, the answer for this and this would be same. Let's see why. Because I cannot, because the difference is actually 0. So I has to remove this whole part. So having 1, 2, 2, 2, 2, 2, 3, 3, 3, 3, 4, 4, 4, 4, 4 is same as having 1, 2, 3, 4. Isn't it, guys? Guys, please respond yes if it is clear to you. Sachin, Abhiram, Ashish. Is it clear? Okay. So now, first we will be removing the duplicates. So if I have 1, 2, 2, 2, 2, 2, 2, 3, 3, 3, 3, 3, I will be simply converting into 1, 2, 3. I want 2, I want 3, I want the duplicates, but I just want their single occurrence, because that is because the multiple 2s and multiple 3s are not contributing to the algorithm. So the first thing, we will be removing the duplicates and then we will be applying the same algorithm. Then we will be calculating the difference and all. So let's move with the code, guys. This is the code for the C. So here, just take the input, and guys, here I am removing the duplicates. If na dot back is not equals to, so guys, if I have, let's see the algorithm how you can remove the duplicates effectively. So I will be creating a new array. Like there are multiple ways to achieve this. So it's totally your choice. So I will be putting this one. Okay, then I will put in this 2. I'll check whether this element is equal to this element or not. So this 2 is not equal to 1, so that's why I'm inserting this 2. This 2 is equal to 2. Okay, not inserted. This 2 is equal to 2. This 2 is equal to 2, not inserted. 3 is not equals to 2. Okay, 3 will be inserted. This 3 is not, this 3 not, this 3 no. 4. Then 4 will be inserted. So you just need to check whether the new array's last element is equal to the current element of the array. If that is the case, then you will not be inserting the current element to the new array. And if they are different, then you can insert it. Okay, this algorithm will work because the array is sorted. So yes, this is how you will be removing the duplicates. Now you have NA, which is new array. And now you are simply applying that count answer, the same algorithm to this. If the NA plus 1 is equal to NA, it means the difference between NA plus 1 and NA is equal to 1, then you will be increasing the count. If this is not the case, then I will be adding count plus 1 by 2 to the answer, which is the C of count by 2, and then making count is equal to 1. When we're done with this whole algorithm, so there will be some value of count. So in the end of this algorithm, we will be again adding the count plus 1 by 2 to the answer and then printing the answer. So guys, that was the implementation of the algorithm that we have seen. Is it clear, guys? Is it clear? Harit, Ashish, Abhiram, Sachin, is it clear? Should we move forward to the D? Okay. So guys, how many of you were able to solve the D? Any one of you? Okay, Harit was able to solve the D. Nice. Very good. Okay. Let's see the D. So we have a game field. Okay, it is a matrix of size of 1 10 raised to the power n cross 10 raised to the power n with a cell at the intersection of Ath row and Bth column. Okay, A and B would be a cell of the matrix. There are n monsters on the game field with the ith monster located in the cell x of I, y of I. Okay. So guys, I have a matrix of 10 raised to the power 9 and 9 cross 10 raised to the power 9, and there will be a monster at this particular cell. Okay, so there will be n monster, and the ith monster will be placed at this cell. Okay, so n monster, so there will be n cells, while the other cells are empty. So guys, n monster is there, then the 10 raised to the power 9 into 10 raised to the power 9 minus n cells would be empty. You can move one monster to any cell on the field that is not occupied by another monster at most once. So guys, uh, we can choose any monster among this n monster, and I can replace this cell by any other cell at most one. Like this operation can be performed maximum of one time. After that, you must select one rectangle on the field. All the monsters within the selected rectangle will be destroyed. You must pay 1 coin for each cell in the selected rectangle. Your task is to find the minimum number of coins required to destroy all the monsters. Okay, let's understand this problem here. So guys, I have a grid. I have a big grid of 10 raised to the power 9 to 10 raised to the power 9. And this in this grid, I will be having n monsters. In this grid, I will be having n monsters. Let's say here is a monster, here is a monster, here is a monster, here is a monster, and here is a monster. So I can choose any one of these. I can choose any one of these, and I can replace its position. So let's say the very first thing is replacement. First thing, I will choose any one of these, and then I will replace its position. So let's say I choose this, and I will replace its position to here, from here to here. Okay, the first operation is done. The second operation is this. After this, I will be choosing a rectangle. After this, I will be choosing a rectangle. Let's say I have choose this rectangle in the grid. Now it is saying in this rectangle, whichever robot exists in this rectangle will be removed, will be destroyed. So there exists these two robots in this rectangle. Now these two robots will be removed. But the cost of this operation is the number of cells in the rectangle. So guys, the number of cell in the rectangle would be the height into the width of the rectangle, isn't it? So 1, 2, 3, 1, 2, 3, 4, 5. In this case, 3 into 5, 15. There will be 15 cells in this rectangle. So the height into it, that is the area of the rectangle. So the area would be the cost. So what I want to remove all, I want to destroy all the monsters. So if I want to destroy all the monsters, so I am supposed to take this particular rectangle. In this rectangle, we have all the monsters. So if I choose this rectangle, and then all the monsters will be removed. So for this, the cost will be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So 5 into 6, this cost will be 30. So the very first operation is to choose a robot. The second operation is to relocate the robot position to any cell. The third operation is to have a rectangle. And the fourth operation is whichever robot that is coming to the rectangle will be removed. So I have to choose a rectangle in such a way that all the robots are covered, because I want to destroy all the robots. So I will be choosing the rectangle in such a way that all the robots will be covered. And the cost of this operation will be the area of the rectangle. Is the problem statement clear, guys? And we want to minimize the area of the rectangle. Is it clear, guys? Is it clear, Sachin? Abhiram? Okay, this is clear. So we want to minimize the rectangle, the area of the rectangle. Okay, fine. Fine. Okay, let's think. Guys, so this relocation part, huh? Let's see the very first thing, which is the relocation. The very first thing of this algorithm is the relocation. Let's say I am currently at here, and the other robots are situated here. So guys, you tell me logically and intuitively, which robot would you choose to relocate? Let's say this is robot 1, this is robot 2, this is 3, this is 4, this is 5, and this is 6. So, Abhiram and Sachin, you guys tell me which robot you would choose to relocate. Robot 1. Okay, we will be choosing the robot 1 to relocate. So, guys, where you will be relocating the robot 1? Where you will be relocating the robot 1? Yes, we will be relocating this robot 1 to this cell. Let's say this cell name is Y or any other cell on top of 2. Yes. Why we are doing so? Why we are doing so? Because we want to minimize the area. If I move this particular robot to this cell, then I will have the minimum area in which all the robots will be covered. So the area of this would be 6 only, and that is the minimum I can achieve. If I am not doing relocation, then the rectangle that will be covering all the robots would be this. So this relocation is actually making a significant change in the cost. This relocation is making the significant change in the cost. But guys, there is a thing that you must have observed. Let's take another example. Then you will see the thing more clearly. You have a robot here, 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 you have a robot here. And then you have a robot here. Let's say you have a robot here. Okay. Now you guys just answer me. I'm just asking a very simple question. Let's say this is the robot 1. This is the robot 1. Guys, would you relocate this robot? Would you like to relocate this robot? Yes or no? Yes or no? Would you like to relocate this robot or this robot? Sachin, Abhiram. Yes. Why we don't want to relocate a robot which is not on edges, or I can say which is in sort of center already? Because idea is pretty simple. We want to minimize the area. We want to minimize the area in which I am covering all the robots. So if I am relocating a central robot, a robot which is coming to the center of the rectangle, then what's the point? So the logic, the very basic intuition says that if you want to minimize the rectangle and you have this privilege of relocating a robot, then why don't you make this operation to the robots which are on the edges? Like if you want to relocate, then relocate this one, then relocate this one, then relocate this one, or relocate this one. Isn't it, guys? isn't it? You guys don't have multiple options. You can perform this operation only one time. You can perform this operation at most once. So this operation is very precious. Then why would you waste this operation to a robot which is already situated in the center? You will pick a robot which is situated at the boundary. Okay, now there are four boundaries only. Now there are four boundaries, either this boundary or this boundary, this boundary or this boundary. How you will check the robots or boundary? So guys, you have x coordinate, you have y coordinate. So you will have multiple x, you will have multiple y's. So you will be sorting this pair by first with respect to x, and then you will choose the minimum, and then you'll choose the maximum. Okay, so we have this x1, x2, x3, x4. I have this y1, y2, y3, y4. Now this point x1, y1, x2, y2, x3, y3, x4, y4, these are sorted with respect to x. Now x1, x2, x3, x4 are sorted, and then we have this corresponding y's. Then guys, you tell me which point will be on the edge. If these are sorted, then which point will be on the edge? Sachin, Abhiram, if I have sorted points, sorted with respect to x, then which of the points will be on the edge? x1 and x4, yes, of course. This first point and the last point, this will be on the edges. Okay, if I sort this array with respect to y, let's say this order change. For this y, let's say I have x2, y2, x3, y3, x1, y1, and x4, y4. For the y, if I sort with respect to y, then we have this order. Now for this particular case, which of the points will be on the edges? y2 and y4, yes. These points will be on the edges. So guys, I will either remove this point, or this point, or this point, or this point. Like x4 and y4 is common actually, yes. x4 and y4 is common. x1, y1, x2, y2, x4, y4 is common. So what we have seen, we will be removing the very first point. Like if I have a grid, let's assume a grid, there would be a grid, and these are the robot which are situated. Then this is the x-axis. So I will pick up the minimum x, I will pick up the maximum x. I will first remove this, and now the minimum will become this, and I'll take this distance. Then I will keep this, and I will remove this, and the next will be this, so distance will become this. So now I have this distance. So for the y, this is the y-axis. So the minimum y I have is this. So first I will be removing this, so the next y is this. And then we have this distance. Or the second choice is to remove this one. Next will be this. So now the next distance will be this. So I can remove either this. If I remove this, then the distance will be what? Then the distance will be this. Distance between the minimum and the maximum robot. This is the x that I got. And if I am removing this, if I am removing with respect to x, then I will not be touching with y. So the y will remain same, y will be this only. Or I can remove this. If I am removing this, then the distance will be this. And again, I am not touching y. If I am removing this, then I will not be touching the x-axis. So my y-axis would be this. My y length would be this, because now the next minimum will be this only. This only the next minimum. This only the next minimum. So distance between the minimum, current minimum, and current maximum and current minimum would be this. Or I can remove this particular element, which is the lowest. So these are the four elements, guys. These are the four elements. Now it is by luck chance that these four are different, but these four could be same. These four could be same, guys. Like not exactly these four, but uh, there can be elements which are like you won't get always the 4 points, because like as you can see this point. So this is contributing to the maximum y and the maximum x as well, isn't it? This point is contributing to the maximum y and maximum x. Is it clear that we will be removing the boundaries only? Is it clear, guys? After removing the boundaries, we will be calculating the distance between the minimum x1 and the minimum x and maximum x, and then we will be calculating the difference between minimum y and maximum y. So I will get the width, I will get the height, I will be multiplying, then I will get the area. So I will be doing this particular task for all the extreme points. So I will be doing this particular task for all the extreme points, and we have seen then there could be at max 4 maximum points, not more than that. Isn't it, guys? Because there will be 4 boundaries, so there could be 4 extreme points or less than 4. So that is it. That is it. This is what you're supposed to do. Yes, I can say this is the implementation heavy problem. If there are multiple points in extreme boundary, can we skip that line? Okay, if you're saying that there are, if these two are lying on the same, if these two are lying on the same x, then you see, if, because you can actually relocate a single point. You can relocate the single robot. You can only relocate a single robot. You cannot relocate multiple robots. So now it's your choice. It's now it's your choice. You can either remove this, either relocate this to the center, or you can relocate this to the center. In any of the cases, your extreme will not change, isn't it? Isn't it? You have choice, you have privilege of relocating only one cell, only one robot. Either you will relocate this one or you will relocating this one. In any of the case, your extreme is not affecting. If you perform operation on this, or if you are performing operation on this, then this will not contribute, because your distance is not reducing. If you remove this, now the distance, your width is getting reduced. But if you remove any of this, now the distance is not getting reduced. This thing is clear? Is this thing clear? So you can apply the naive algorithm. Just pick the extreme points. If there will be multiple extreme points, then the answer will not be effective. The answer will not affect. If there would be a single extreme point, then the answer will be effective. So you just pick the extreme point and remove it and see for all the extreme points. You will get the answer, isn't it? For we have seen both the cases. In this case, extreme is not affecting. Okay, if extreme is not affecting in this direction, then I'll go with the vertical direction. So now there might be a case then in vertical direction also there are same extremes. Okay. Now what I can do? I can do nothing. If I move this to this, then again the extreme will be the same, na? So like this is something that what we can do. What we can do in if I have multiple points on the extreme, it means the extreme, if it means the length cannot be reduced, the rectangle size cannot be reduced. But we don't care if we have multiple points on the extreme. If we have, then the length will not be reduced. If we do not have, we have only single point on the extreme, then the length will be reduced. So yeah, we will be removing the extreme point, and the length we will be removing the extreme. The extreme would be the lowest and the maximum on both the directions, and then we will have updated length, and then we will be calculating the updated areas, and out of those 4 areas, whichever will give us the minimum answer, we will return that one. Guys, is the algorithm clear? Is the algorithm clear? That confusion of multiple points on the extreme is clear, because if we have multiple points on the extreme, then that in that particular direction you cannot reduce the length. Yes. So if we have multiple points, then I am removing the one, because the minimum of this one would be this. If you sort the points with respect to x direction, then this will come first. So simply you remove this. Now the second minimum is what? This is the second minimum. The difference between the second minimum, second maximum, and minimum will remain same. Okay. Okay. No issue. Now there is nothing I can do, because I have privilege to move only one robot. You could have picked this one also, but that won't make any difference. Okay, so algorithm is clear. Now let's move to the implementation part. Okay, so guys, let's see the implementation. Now there is not a particular way to implement this. Now it's up to you which programming language you are using and how the sorting works, because we have this array of x comma y. So let's see a single approach. Like there will be multiple approaches. Let's see what I have choose. So first, like there will be so I have this. First I will be sorting with respect to x. First I will be sorting with respect to x. So once I am done with the sorting with x, then I will be removing the first one. Then I will be removing the second one. First I will be removing the first one and then calculating the x distance and y distance. Then I will be removing the last element, and then I will be calculating the distance between the maximum and minimum x and the maximum and minimum y, and then calculating the area. Then I will be swapping their positions, and then again I will be sorting with respect to x, because now I have y on the x. So it means effectively I am sorting with respect to y. Then I will be removing the first and calculating the x and y, and then I will be removing the last and calculating the x and y. And then we'll have 4 areas, and out of those 4 areas, whichever will be minimum, we will be returning that. Okay, let's see. So I have taken the input of the array. So first I have already sorted the array. So by default, if I am sorting, so it is sorting with respect to this x direction, like the very first dimension. Okay, I have sorted the array. So I am taking this solve function. In this solve function, I am computing in the solve function. Here is the solve here. Okay, guys, wait. This D, yeah, okay, guys. Here is the solve. Okay, let's see here only. So in the solve, I am iterating from 1. I am skipping the first element. Here I am skipping the first element. I am iterating from the first, and here I am calculating the minimum distance, minimum direction, minimum starting point, and then like these are the two extreme in x direction, and these are the two extreme in y direction. Then I am calculating the width and height, and then I am giving the area. Okay, so this particular observation we will see, but this is how the algorithm is going. So we will calculating the area, and I am returning the area. Then I will be reversing this sort and doing the same stuff. After reversal, the very first element would be the maximum one. So it means effectively in this I will be removing the maximum element. In this I will remove the smallest x. This will remove the maximum x. Then I am swapping the x and y. So this will remove the smallest y, and this will remove the maximum y. So I have 4 answers, and out of these 4, I will take the minimum and return the minimum. Okay, now let's come to this last thing. Guys, what would you do if you have elements in this order only? Now what would you do? Now what would you do in this case? We have points on the extremes only. We have majority points on the extreme. And the area is actually equal to the number of cells. Here I have 9 cells, and the maximum area after this algorithm is coming 9 only. Coming actually, it is coming less than, because guys, you have removed a point. You guys have removed a point. Okay, for this, let's see this test case. Let's see this test case. In this particular case, you must have removed this. Your algorithm must have removed this, and your area comes out to be 4. And in this particular case, the area is coming out to be 4. And the total number of points were given 5. Originally, this point was there, but we have removed this point. So the total number of point was 5, and the area after applying the after removal of the element, we will get the area as 4. Why it is happening? Because we don't have, it means we don't have any empty cell to relocate this particular element. Now this element could be here also, like this particular element exists somewhere like far from here, like these are the empty cells. But again, in this case also, your algorithm will be written 4, because the algorithm will be removing this element. So in both of the cases, it means we don't have a in between gap for this x. So whenever this condition occurs, that your algorithm is given the area which is less than the number of elements, so it means it is very simple. Now how you will be managing the case, guys? Okay, let's see how you will. Now you guys will be answering only, like you have this case, and now there is one outlier that you have to fit. In which direction you will be adding the x, here or here? You guys tell me. If you guys add the x here, now the area will be this, which is 9. If you add x in this direction, now the area will be this, which is 8. Let's take another example. You guys tell me in which direction you will add the upcoming x. Yes, the dimension which is less, which has less number of elements. So in this direction, which is 3, and this is 4, so it means I will be adding in this 3 direction. So I will be adding here x. So this particular layer will be increased. So I will be adding this here. So whichever dimension is less, I will be incrementing my area by that dimension only. So that is why for that particular case we have this. If the area is less than, is not greater than or equal to n, if the area is less than the number of cells, it means you supposed to increase a cell. Which cell? Which dimension? Like you can have x here. So if you have x here, then you will be increasing the height. You will be increasing the area by height, or you can increase the area by a width. So I want to minimize the area. So that's why the minimum of height and width will be increased. That is the only thing that we have to see. That was the edge case. That what if all the elements are situated in a congested place? So is that was about the D. Is it clear? Do you guys have any doubt regarding the fourth problem? Sachin, Abhiram. So guys, that was about today's upsolving session. Hope you must have learned something, you must have enjoyed, you must have thought that how we should tackle the problem, how we should proceed with the problem, with the test cases and with the observation. So that was about today's session, guys. Good night. Thank you.
So, hello guys, with the name of God Ram Ram. This Codeforces problem E was based on a very popular trick which you must have encountered if you have studied and solved many problems on prefix sum on arrays and Kadane sum. Okay. So before I discuss this tree problem, it's very important that I discuss the standard technique of trying to find maximum subarray sum ending at index I. Okay. So let's say I give you an array, okay, just for your practice I'm giving you an array here. 5 minus 2, then 8, then 3, then 1. This is the array B given to you, or array A. You can change the naming convention. In the document, I have called it as array A. Okay. So if you want to create the prefix array, like if you are watching the video till E problem, I assume you know what is the prefix array, right? So if you try to make the prefix array out of this, what is gonna happen? Well, if you try to make the prefix array out of this, you have to write the sum of these numbers, right? This is 5. Sum of these two numbers 5 and minus 2 is 3. Sum of the first three numbers 11. Then sum of the first four numbers, right? Like just trying to make you feel these things. 14. Then you know the sum of the first five numbers, right? And the sum comes out to be 15. This is called as prefix array. So you guys understand the meaning of prefix array, right? 5, 3, 11, 14, 15. 5, 3, 11, 14, 15. So you understand that prefix of I is nothing but what? A1 plus A2 plus the sum of all the numbers till index I. So in O of one time, if you have pre-calculated the prefix array, you can get prefix of I as A1 plus A2 till all the numbers AI. If you do not know these things, don't worry. I will attach the link to the prerequisite warm-up DSA course of mine in the description or somewhere, and if you do that course you will understand what I'm trying to say. So first do that course, okay? In that prerequisite course many good videos are there on prefix sum, hashing and trees. If you watch those videos, then this problem is a cakewalk for you. Cakewalk. In codeship they call it cakewalk, right? Anyway, so you know the prefix sum, right? Now guys, I want to introduce a new type of array, which is the max of I. Max of I means what? This is an array given to you. You are at index I, okay? So max of I means you will consider all possible suffixes. This is array A. You will consider this guy. Max of I can either be AI or or it can be the sum of either the ith number or it can be the sum of the last two numbers I and I minus 1. AI plus AI minus 1. Or it can be the sum of the last three numbers. I hope you got the idea, right? Baby, you got the idea. AI plus AI minus 1 plus AI minus 2. So that's what I wanted to clear in your head, okay? And there are many more options, right? So you can see max of I is nothing but at any index I want to compare all the subarrays which are ending at index I. So guys, which are the subarrays which are ending at index I? I hope you can imagine the subarrays which are ending at index I. If this is I, one subarray ending at index I is I. Another subarray ending at index I is I minus 1 comma I. Another subarray ending at index I is I minus 2 comma I minus 1 comma I. Another subarray ending at index I is I minus 3 comma I minus 2 comma I minus 1 comma I. Another subarray ending at index I is I minus 4 comma I minus 3 comma I minus 2 comma I minus 1 comma I. So these things you deeply understand inside your head, and these things really make it easy for you people, okay? Clear? Great job. Nice. Awesome. Now guys, you need to increase your focus as much as you can. Increase your focus as much as you can, okay? So guys, one brute force way to do this is that you will calculate all possible suffix sums, right? You will calculate this, then the sum of these two numbers, this, but it will take n square time if you have to calculate this for each index I. I want max of I for all the indices from I equal to 1 to I equal to n. Max of I is this thing. So if I try to show it to you here, max of I is nothing but AI or AI plus AI minus 1 or this or this or this. So guys, trying to give you a final visualization. Always start everything with the name of God, Ram Ram. So max of I, like if I try to show you in this format, 1 minus 3, then 2, then 4, then 5. This is, let's say, array B. Let's say I try to make a max array. What will be max of 3? Max of 3 has these options. Either this is index 3, right? So max of 3, right? 1, 2, 3, 4, 5. So max of 3 means consider all the subarray ending at index E. One subarray is this, which is B3. Another subarray is this, B2 plus B3. And the last subarray ending at index 3 is B1 plus B2 plus B3. Calculate answer of all of that. B3 alone is 2. B2 plus B3 minus 3 plus 2 minus 1. And minus 1 plus 1 0. So guys, which is the best answer? 2 or minus 1 or 0? 2 is the best. So max of 3 is 2. So basically you considered all the 3 subarrays ending at index 3, and the best, the subarray with the maximum sum is the answer of max of 3. So guys, that's it. Done, 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 done. But there is a technique. This formula I have taught in my course. Make sure you study my prerequisite course to understand this. The trick is that from now you just remember this trick. Max of I is nothing but there are only, like, you can combine all these options in just two options. For example, uh, max of 3, for now there are so many options, right? A of 3 or A of 3 plus A of 2 or A of 3 plus A of 2 plus A of 1. My technique is that max of 3 is only two options. One option is A of 3, another option is A of 3 plus max of 2. How is this valid? See, A of 3 option I'm considering here also, so no difference. Another option is just this A of 3 plus max of 2. This A of 3 plus max of 2 is equivalent to these two options. Why? Here, in both the options, you are considering A3. Here also there is A3. Now you just need to know now that in these two options, who is going to win? This or this? For that, you need to know which is bigger. A2 is bigger or A2 plus A1 is bigger. Which is bigger? Is A2 bigger or A2 plus A1 is bigger? Max of A2 plus A2 comma A2 plus A1 is nothing but max of 2. Oh my goodness. So max of 3 is nothing but either you go with A3 or you go with A3 plus whatever the max sub array you are getting, which was ending at index 2. So you have clubbed these things into just two options, and now you can just run a loop and you can know the maximum sub array sum ending at index I was just writing this. Max I is nothing but max of A of I. Either you just take the current number or you take the current number plus the best subarray sum ending at index I minus 1. Always respect your mother and father. Listen to them. And please have faith in God. Ram Ram. Make them happy. Now, listen to me carefully. Very, very carefully. But first, make your own self happy. But guys, now what if I change the definition of the sum? What if I start demanding alternating sum from you people? Then will you sit and cry? So let's say this is an array. Okay. Let's say this is index 5. Now the definition of sum has changed. Now the sums are alternating in nature. Now the sums are alternating in nature. What is the meaning of that? Now there are two kind of values. Positive, like max positive I. Yeah, max positive I. Earlier it was just max of I, max positive I. Max positive I means this number will be taken with plus sign, this number will be taken with negative sign, this with plus sign, this with negative sign, and this with plus sign. So many options will be there now, right? One option will be what? A5. Another option will be what? Minus A4 plus A5. Another option will be what? A3 minus A4 plus A5. Another option will be what? Minus A2 plus A3 minus A4 plus A5. Another option will be what? A1 minus A2 plus A3 minus A4 plus A5. Like one option, two option, third, fourth, fifth. You need to know the max of all of these. So for each index I, let's say I equal to 5. Let's say I equal to 5. So you know this subarray you considered, then the subarray ending at index 5 but last two elements, then last three elements, then last four elements, then last five elements. These are all possible subarrays. Now guys, what will you do? Will you sit and try? No baby. Again you can use a similar type of solution, but I know this might be coming in your mind, right, sir? Max positive I can reduce it to something like this, sir, right? Either it will be a5, which is nothing but a of I, or it will be ai plus the max you were getting till 4, but the sign of 4 will be different. Can you see? In like you have to make convert all these into second option. Can you club all these into second option? You can club these all in second option. See, a5 is common in all of them. So I have written here. Rest of all the sums, can you see they all have negative a4, negative a4, negative a4, negative a4. So if you know the best negative sum ending at index 4, then you can write the answer as ai plus max negative I minus 1, and that solves your whole problem. So max positive I, like max positive I is what? Max positive I is nothing but max positive I means, you understood na? Max positive I means you have to consider all these options. If I is equal to 5, you have to consider a5, then a minus a4 plus a5, then this sequence. Max of all of them. Now one way is to do brute force and generate all these sums. It's n square time complexity, because for each index I, you need to travel all the numbers from, you can see, right, from 5 till 1 to generate all these sums. But you can do it by just writing a simple formula. Max positive I is what? Max positive I is nothing but either you take a5, which is ai, or you take ai plus max negative I minus 1. Means if you considered all the negative sums ending at index 4, whichever one was the best of them, add them with a5, and all these options will get considered as the second option. This option automatically takes max of all these possibilities apart from a5. This a5 is congruent to this a5, and all these 1, 2, 3, 4 options are equivalent to ai plus max negative I minus 1. Such a brilliant observation this is. Okay, so max positive I means what actually? It means either you take ai, or you take ai minus 1, or you take ai like this, like this, like this. You will consider, everything. You will just take max of all of them. You will just take max of all of them, baby. And max negative is also the same thing, but the thing is that you start with a negative sign, minus ai Okay, minus AI, minus AI, then minus AI plus AI minus 1, then minus AI plus A of I minus 1 minus AI minus 2. Like this till the end, you will take all the possibilities. So the shortcut way to write this is, one option is you take AI, another option AI plus max negative I. Similarly, even though we don't want to calculate max negative I, but we need that because you need to calculate all max negative I, because max positive I formula is dependent on max negative I minus 1. So, like, sorry for that, it's not negative I, it's max negative I minus 1. Okay, so just let me show you such a brilliant insight I've given you. I know you must have enjoyed this thoroughly. So just let me cut it up, guys, for you people. Okay, so this will be nothing but max of A of I, comma, not A of I, max of minus A of I you can take, or you can take minus AI plus max positive I minus 1. Okay, and that's it, guys. Now you can confidently say that we have solved the problem for the array. Guys, do you understand? If I give you any array, like, let me try to write the array in circle format. Okay, node 1, node 2, node 3, node 4, node I equal to 5, like this. Okay, let's say this is your array and the numbers are there in your array. Okay, which you can call as a tree also. So guys, what is max positive max, like, let's say this is the root of the array, or you can say root of the tree. What is max positive phi? Max positive phi means, let's say this is A, right? A array. It means you have considered all these options. Which options? This sum, this sum, this sum, this sum, and this sum. You have considered all of them, and you have taken max of all of them. Max of all the options you have taken. One is A5, another is A5 minus A4. There is alternating sum, be careful about that. A5 minus A4 plus A3, A5 minus A4 plus A3 minus A2, A5 minus A4 plus A3 minus A2 plus A1. Max positive phi means you have considered all the paths which end at node 5. This path, this path, this path, this path, all the way to the root of the tree. So max of all of them you are printing. The question, actual question is saying this only. For each node I in the array, if you consider, let's say, the array, you have to print max positive I for all the I from 1 to n, which you can simply do, just run a for loop, just run a for loop beta and calculate max positive I, max negative I. Like, sorry, I don't have to write an I minus 1, I. And once all has been calculated, just print from 1 to n the max positive I. But guys, this problem also, you solve this for an array, right? It means you also solved it for a linear tree. Linear tree. Tree means what? Make sure you watch my prerequisite course to understand what's a tree. Tree looks like this. Node 1. Node 2. This is called as the root of the tree. This is child of node 1. Then node 3. Node 4. Node 5. Node 6. Node 7. Node 8. Now, what is max positive 8? Max positive 8 means consider all the vertical paths till the root, which is what? This node sum, get it done. These two node sum, get it done. Alternating sums, right? These two node sum, get it done. These three node sums, get it done. These node sums, get it done. these node sums, get it done. Can you see, it is just like an array. You can imagine this tree to be an array. Solve the question for the array and the whole problem is solved. I will try to show it to you in different ways until it's 100% clear in your head. I think nothing is more important than deep understanding in DSA. As per the question, max positive phi means you consider all these paths. Path phi, then path of 4, like 4 comma 5, then you consider the path of 3 comma 4 comma 5. Basically you have to consider all the paths which are going upward from phi. This one for max positive phi, or 4 phi, or 543, or 5432, or 54321, or for any particular node. If you consider all the vertical paths going up, ultimately they will reach the root node of the tree, which is the topmost node, node number 1. So you consider all possible paths, 2 3 4 5, and then 1 2 3 4 5, and their sums are alternating in nature. I taught you, right? A5, then minus a4 plus a5, then a3 minus a4 plus a5, then minus a, like minus a2 plus a3 minus a4 plus a5, then a1 minus a2 plus a3 minus a4 plus a5. Okay, you need to know max of all of them. You can get this answer in O of one time, because I taught you how to calculate max positive phi. Convert this tree to an array. Array will look like this: 1 2 3 4 5, and max positive phi you will calculate using this. If the tree is linear, convert this to array. An array means this only, na, 5 and then 4 5 and then 3 4 5 2 3 4 5 1 2 3 4 5. The best alternating sum max of all of them, which has been calculated here using this formula. So guys, we have solved this problem for a linear tree. Now the people will ask, sir, how do we solve it for a general tree? Well, do the same thing. Just use BFS and do the same thing. For general tree, we do BFS and apply the same formula in BFS of each node. General tree looks like this. If you don't know BFS, please go and study. I have attached the link to the course in the description. Study it first. Now, if you want max positive phi, do you know which paths you will consider? All the paths which are going upwards towards the root. One path is what? You consider only node number 5. Another is the vertical path above 5 and 4. Another above 4. The parent of 4 is 1. This 5 and 4 and 1. So now you will say, sir, what will be the formula, sir, of max positive phi? Again, there will be two options only. Max positive phi. Either you take this node value a phi, or a phi plus max negative 4. Max negative 4 will be consisting of what? Only these values will be considered. Max negative 4 means earlier you were considering, see, earlier when you were at node I, earlier in the array, when you were at I, what you were considering? You were considering this, max of all of them, and the answer was getting pointed to I. When you have a tree, you do the same thing vertically. Can you imagine or not? Node 1, node 2, node 3, node 4, node I. Now what you will do? This, this sum, this alternating sum, this alternating sum, whatever the max is the answer of max positive I. Same thing you will do even if the tree is not normal. Even if the tree like this. Now for 5, what you will do? This sum, this sum, this sum, and this sum. 2 you will not include because 2 is not in the vertical path. Got it? So here max positive 5 considers only this, and this. 5, 4, 5, and 1, 4, 5, because parent of 5 is 4 and parent of 4 is 1. Each node has only one parent in a tree. So how can you write these things easily? The hard way to write this is what? A5, then A5 minus A4, then A5 minus A4 plus A1. Easy way of writing is this what? The first option A5, which is written here also. Next, A5 plus max negative of A4. So we are saying A5 plus max negative of A4. Max negative of A4 means consider all the negative paths, vertical paths ending at 4. So one negative path ending at 4 will be A4 only, minus A4. Another negative ending path at 4 will be minus A4 plus A1. Minus A4 plus A1. So max negative 4 considers both of them and takes max of them. So max of minus A4 comma A1 minus A4 is considered in this. Then you are adding with A5. So these two options are automatically getting considered. Oh my god. So the full problem is solved. You just do a simple BFS, guys. BFS means you will travel the tree level order wise. Okay. Like hopefully it cleared up in your brain many things which it should have cleared. Okay. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. You will do the same algorithm. The only way will be the how smartly you travel. So first you will travel the level 0. Level 0 you need to travel. First you need to travel level 0. Then in BFS, this is called as BFS. Don't worry, I have attached the link in the description. Study from there, you will understand that. It's a very hard level problem. Still, I'm trying my best to explain you from a scratch level. Then you will travel all the nodes at level 1. Then you will travel all these nodes 4, 5, 6, 8 at level 2. Whenever you are at a level, let's say max positive 2 you want to calculate. Max positive 2 is what? Max of A2, which you already know, comma A2 plus max negative of the parent. Who is the parent? 1. So you will say, sir, but how do we know max negative 1? We already know max negative 1 because we started the traversal from here. When I was at 1, I already calculated max positive 1 and max negative 1. Then I come at 2 and 3. When I'm at 5, let's say I want max positive 5. What will be the answer? Either it will be A5, which I already know, or A5 plus max negative 2. You will say, sir, I am at 5. How do I know max negative 2? You already know because first you traveled node 1, then you traveled node 2, then 3, then 4, then 5. So when you are at 5, you have already traveled through. Means max positive 2 and max negative 2 have already been calculated. Wow, Ram Ram. My goodness, this is like truly a brilliant problem. Max positive 5, max negative 2, max positive 2, max positive 5. Okay, so I will try to show you the implementations now. Okay, like always, make God the center in your life. Okay, because all the energy which you want and the thing you want, the power, the propellants towards your final goal will come only from the power of God. So never forget God. Okay, most important in your life should be God. Ram Ram. So now let's go and check the code, baby. So obviously, guys, I am Kumar K. I did not give my introduction, but this E part is taken by me, and I am Kumar K. So hopefully, guys, you are understanding it and you are enjoying it as much as possible. I just want you to fall in love with DSA. You can see my struggle journey, how much problems I faced during my journey few years back. I don't want you to go through that journey, problem. I want you journey to be smooth. So just fall in love, fall in love. That's it. So guys, in the code you can see I'm doing just a basic BFS, okay, and best. This is max positive one. This is max negative one. You can see A1 and then minus A1. For node number one, you can calculate by hand because node number one will never have any parent. You can see root is at vertex one. So node number one will not have any parent. Okay, that is like clear. Okay. Then guys, you can see max positive V or best of V is A of V plus A of V plus max negative parent. U is the parent of V in the BFS if you know this thing. Same goes for max negative V is minus AV or minus AV plus max positive U. U is like in the BFS. I hope that you know that when we are at U, we iterate all the children of node U, and you can see V is the child. V is the child. You can see that. Okay. So same thing has happened in the code, and for each node I have just printed the best positive sum. I've written here best 0 V, best 1 V. Best 0 means max positive sum of node 1. 1 means max negative sum of node 1. Like this is 1, but it will become 2, 3, 4. It will become IUV depending on what you want. Hopefully you guys enjoyed it. Ram Ram. Ram Ram.